Hi everybody, it's Mr. Mott. I'm going to go over some strategies involved when you're doing some heat calculations. So there's going to be a couple main strategies that you're going to use when you approach a heat calculation. So first of all, you're going to recognize it's a heat calculation. They're going to have masses, usually temperatures, things like that. Now, as you read, there's going to be two main types of problems. You're going to read through the problem, and from there you're going to develop your strategy. Two different types of problems that you're going to have. You're going to have it's going to say basically, usually you have a metal and you have water. Okay, so that's going to be one strategy or one type of problem you're going to have. And the other one is going to involve some type of phase change. So they're going to be either talking about, say, ice going into water usually, or water going into steam, or maybe even a combination of them. But each one has their own kind of strategies. The first thing you want to do is, okay, you want to read through it, and from there you can develop your strategy. If you're dealing with a situation where usually it's a metal that's hot and the water that's colder, the strategy that you want to use right away is that you want to make a T-chart. T-chart is going to be very helpful to organize all that information. Okay. So the T-chart is going to have your mass, your specific heat, and your T-final and your T-initial. Okay? So that's going to help organize all your information. Once you do that, we have our main idea that the heat that is absorbed is equal to the negative of the heat that's released. All right? That's sort of the main idea. And you don't necessarily have to write that down when you're going ahead and solving it, but it's a main idea. From there, what we do is we set up MC delta T equals negative MC delta T as our main formula that we're going to use. And remembering that whatever is absorbing heat, all that information is going to go here. Your mass, your specific heat, maybe your temperatures, whatever you're absorbing, and then whatever is releasing heat, all that information is going to go on the right-hand side, the one that has the negative in front. If you're not sure about which one is absorbing and releasing, you need to look at the initial temperatures. So if your water starts out at 20 degrees and it ends at 30 degrees because the temperature went up, you know that it must have absorbed the heat. So typically that's with water is on that side, but you do need to look within the problem. Okay, and so that's the main idea, and you're going to have one unknown on either side that you're going to solve for usually. Okay. The other type of heat problem that you're going to encounter is when you have a phase change. Okay, again, so you're going from say ice to water or water to steam usually. Okay. So with that strategy, what I'd like you to do, and I find very helpful, is going to be draw and label a phase change diagram. Okay. So draw and label the phase change diagram. So you want to make sure on that phase change diagram, it's going to look... when you draw and label it, you want to make sure you put like the whatever temperature that you start with, the temperature that you end with, and then also you label the flat part of the graph. Okay, label that flat part of the graph. All right, and so from there, once you have your phase change diagram, as far as your formulas, you're going to have separate formulas. So you're going to have separate formulas, and usually what that means is that your separate formulas are, you have Q equals MC delta T, and you're also going to have Q times delta heat, and if you're in the melting portion, it's going to be the heat of fusion. If you're in the liquid to gas, like in boiling, it's going to be the delta heat of vaporization. So you're going to have multiple formulas. The other thing you need to keep track of is for your C value, keep track of the state of matter. Is that going to be a solid? Are you at a solid? Are you in a liquid or in the gas phase? Because the specific heats for those things are a little bit different. Okay? To show you what I mean by the phase change diagram, at the bottom what it would look like, let's say that we're going from a solid to a liquid. Okay? We'd have something like this. Let's say we started out at, say, negative 50 degrees. This is going to be temperature. Okay? And then we're going to negative 50 degrees of ice up to, say, 75 degrees. So I'd label 75 degrees up here. And thinking about what this flat part would be, at what temperature does it start to go flat? Maybe you want to take a second to think about that. All right, so if this is water or ice, when ice gets up to 0 degrees, its melting point, it will start to melt. Okay. Now, as far as your formulas, anytime you have a change in temperature, you're going to use Q equals MC delta T. So right here and here. And then you're going to use Q equals M times delta heat. If this is for ice, it's going to be for fusion. Okay? This would be the C value of ice. This would be the C value of H2O water. Okay? Zoom in a little bit for you so you can kind of see that. All right? And I would even actually label 0 over here. Okay? So that's in general what it'll look like. All right? I've done another video on going through ahead and solving that, so you can check out RMHS Chem for that other video. For your heat calcs involving Q equals MC delta T, what you're going to have is your T chart is going to look like usually you'll have water on one, and then you have your metal on the other, and you're going to have M, C, T final, T initial on both sides. Sorry about that. Here we go. And then M, C, T final, T initial on both sides. Things you can automatically fill in here. The specific heat of water we know. Okay. And from the problem, you're going to have to identify everything else. So once you've got your strategy, once you know what type of problem it is, just as kind of a little bit of a review here. It's important to be able to recognize from the problem, what strategy to use. Okay, so strategies can help you kind of organize your information. It's a real nice visual to have down. And then from there, it tells you how to go ahead and solve it. All right, thanks for watching.